Hey guys, welcome to your last Ed puzzle of the year. We're on 10.5, graphing square root functions, woohoo! By the end of the day, you'll be able to graph square root functions and to translate them. Not translate as in like in Spanish. Translate means, I guess I should go this way. Translate means move, or like you shift the graph over. So let's get started. The parent function of all square root functions is y equals the square root of x. So as we take our x's, we plug them in here, we get that the square root of 0 is 0. The square root of 1 is 1. The square root of 2 is kind of weird. It's 1.414, and then it's an irrational number. It's gross. So since the square root of 2 is yucky, I'm only going to do perfect squares for my x's because I'm allowed to do that. I can pick whatever I want my x to be. The square root of 4 is 2. The square root of 9 is 3. So those are going to be my points. So I go over and I put them on. Okay, 0, 0, 1, 1, 2, 1.4 is going to be a little bit less than a half. So there you go. Okay, 4, 2, 9, 3. And this guy does not grow very fast. Ha ha. Now some people say, well, technically the square root of 0 is, the square root of 1 is plus or minus 1. Square root of 2 is plus or minus. Plus or minus, plus or minus. So let me show you what happens if you did that. You'd have negative 1, negative 1.4 over 2, over 4, negative 2 over 9, negative 3. And then you have a little wee. And if you take that shape, you guys have seen this shape before. Do you know what shape that is? You guys, this is a parabola. This is a normal parabola, y equals x squared. But all it is you shift him. I wish I could make it pivot. Oh, I totally can do this. Okay. Okay, so you take our normal parabola. Oh, it's going to be brilliant. And then you just rotate him. Isn't that legit? That's amazing. That's so cool. It's the highlight of my day. Okay, anyway. That's exactly what it is. However, as soon as we rotate this guy, he's no longer a function. He's not a function because now he has 2 y values for 1 x value. So in order to make it a function, we only take the positive value and we get rid of all of our negative friends down here because we don't need their negativity anyway. Sweet? Sweet. Now, speaking of no negatives, we also cannot plug in any negative x's because you can't take the square root of a negative number. Yeah, sure, square root of 4, that's 2. Square root of negative 4, that's not a real thing. Square root of 0, that's fine. Square root of 0 is 0. But our radicands, what are we plugging in here? They cannot be negative. No negativity. So today we're keeping it positive. Our domain is x, where it's all reals, where x is greater than or equal to 0. All real numbers where x is greater than or equal to 0. That's our domain. Our range is going to be the same thing. Because notice we don't get any negatives out. Then it wouldn't be a function anymore. So our range is y, all reals, where y is greater than or equal to 0. So in a nutshell, you guys, we are keeping it positive today. Cool? Cool. Let's find 2 things. First, we're going to find the domain of each function, and then we're going to graph the functions. Okay. So we find the domain by basically figuring out what can't it be. We need to find out what would make this negative, because then that can't happen. Sweet, sweet. Okay, so we look at our radicand and we figure out what would make 3x minus 9 be negative. So where is 3x minus 9? What needs to happen for 3x minus 9 to be greater than or equal to 0? Well, let's find out. We add 9 to both sides. That gives us 3x is greater than or equal to 9. We'll divide by 3. So we get x is greater than or equal to 3. And that's our domain. As long as x is greater than or equal to 3, then a radical will be positive, because we cannot have a negative radical. Ta-da! Let's do it again. How do we make this guy? What's the domain here? Well, first of all, we need to make our radicand greater than or equal to 0. So what is 2x minus 5, negative 2x plus 5. What does that have to be in order to be greater than or equal to 0? Well, as we're getting x by itself, our next step is to undo that times negative 2, so we're dividing. We get x is greater than or equal to negative 5 halves. I like fractions, so I'm going to leave it like that. If you want to say, wait a second. I did this wrong. My bad. I did 2 things wrong. Okay, we need to subtract 5, which gives us minus 5. And then also, when we divide by negative 2, we need to flip that guy around. So we get x is less than or equal to 5 halves. That's what you get for going fast. Always check your work, you guys. Okay, in order to find the domain, your radicand must be positive. So take your radicand, figure it out, and radicand needs to be greater than or equal to 0. That's a heart. Okay, sweet. How do we graph the following functions? Well, we can start out with our normal. I shifted it down, didn't I? Oh, well, the scale's still going to work. So a great way to graph is to take your normal function. Ta-da! We scale him down so he fits on our graph. Look, guys, we did it. And we're going to make him gray because he's the parent function. All parents go gray with time. Anyway, and then what happens here is when we have a shift outside the radical, like this, that will tell us that we need to go up that much. So we're going to take all of these points, and when we add 2 to them, they all go bink, bink, up 2. So a number outside the radical represents a shift up 2. So cute. Now if we have a number inside the radical, inside our radicand, that represents a shift to the left. Excuse me. So we take our original, I'm gonna have to do this all over again, Nope, I'll just do that. Call it good. Nice. So good. And then we don't need our shift uppy guy, but instead of a shift up, we are going to go to the left 3. 1, 2, 3. Boom, right there. We take our normal square root and we move him back 1, 2, 3. And that's our new graph. So great. I just saved you so much time because yes, you can totally make an XY table and I promise you they'll come out the same. But you have better things to do with your time. So here's the shortcut. If you start with your parent function, y equals the square root of x plus h, well, x. Okay, fine, we'll do x plus h plus K. That represents a shift left H and up K. And that's what's up. I hope you have a great time on your homework.